I'm Julie McGee. I'm going to introduce this session and the next. I'm Semtech's Chief Marketing Officer. Happy to be here with everybody. We have an exciting topic about the Panama Canal. Thank you, Sarah, for moving up. And especially for all of you that have stayed. Carlos from Kerlink is here, and Eric from Senzary. Is that how you say it? Perfect. We're going to talk about the Panama Canal and using LoRaWAN to measure emissions and sulfur dioxide emissions, so it should be an exciting topic. I did not know this, but almost, 31,000 vessels go through the Panama Canal every year. I tried to do the math on the number per day, and it was astounding, actually. So if you gentlemen want to come up, thank you for coming today.
Well, thank you very much. We have a full house this afternoon. Yes, thank you. Well, thank you for all of you that showed up for the call, for the presentation. That means that this is important, and you are excited to hear about this. And thank you. Thank you to the LoRa Alliance for organizing the event and for the opportunity for us to present the project with the Panama Canal. Obviously, the Panama Canal has a big name, so we're very excited to talk about this. So I'm Carlos Briceno from Kerlink. I'm going to just briefly present who we are, how we participated in this, and then I'll hand it over to Eric to speak in more detail. So just a quick Kerlink for the ones that know and the ones that may not know about Kerlink, just a refresher. So Kerlink has been around since 2004, always in IoT. We've been in LoRa since the beginning. We're proud to say we're a founding member and a board member of the LoRa Alliance. We specialize in the network components. So we provide, we design, we produce, we distribute the components necessary to put out a LoRaWAN network. That includes the hardware, services, and software. So today we have more than 200,000 installations all over the world, 75 countries, in all kinds of use cases, from small to large. We're a true global company. We're headquartered in France, but we have subsidiaries in India, in Tokyo for Japan, Singapore for APAC. Here in the U.S., we manage the American continent, and obviously from headquarters, we manage Europe, Middle East, and Africa. So, with all these customers that we have, there are so many applications, as we know, with LoRaWAN can apply from small to large solutions, but they mainly focus on three categories. What we find. Smart agriculture and environment. So this is cattle, agriculture, how to measure the environmental pollution, and different things. Smart buildings. Examples are smart hospitals, hotels, campus, industry, asset tracking, predictive maintenance. There are things that we have already heard about, smart cities and quality of life, and that encompasses actually probably the rest of things. Obviously, smart cities have many use cases. Quality of life encompasses health and other things. So for us and for the industry, one of the approaches to solutions is important. How do we bring a solution to the market? What is the best way to engage a customer? So at Kerlink, we made an effort to create an ecosystem, and we've created a partner program that enables customers to be served and to receive solutions that are specifically geared for their needs. We're not trying to, at Kerlink, to try to cover everything and offer solutions for all different industries. We work with partners that are specialists in those areas, so they know the market, they know the customer, and so the customer can receive the best solution available. So today at Kerlink we have, the partner program encompasses more of a channel approach where the products, Kerlink products, are available for the end customers or solutions providers or integrators. And also the business part of the program. These are companies that are leading the market, that leading in their industries. And an example, obviously, here is Senzary. So the Panama Canal is actually a very interesting and very, it's a nice project to be part of, because in our mission statement, we mention protect the environment. And this project with the Panama Canal has to do with the environment, as obviously there are some business attached to it, but what the driver is the environment. So it's just to the challenge that the Panama Canal in any ports or areas that deals with ships is that sulfur dioxide, the emissions by ships is about 10% of what humans produce for sulfur dioxide. And obviously, when there's a concentration of ships, whether ports or the canal, this challenge, this pollution becomes even greater. Actually, the number of vessels that go through the Panama Canal is about, it's a little over 13,000 per year. Now, that's quite a bit of, if you divide it by days, it's quite that's a lot of ships going through one area, and fairly small area. So, obviously, if I mention the sulfur dioxide effects, it has to do with the respiratory system, makes it difficult to breathe for humans, for trees and plants, and then it affects their growth, and what we've heard before as acid rain. So the objectives, what the Panama Canal wanted to accomplish with this is to keep it as pollution-free as possible, to minimize the effects of this pollutant in that area. So, and then also to help shipping companies meet their clean air regulations. So their idea from there, and help from Senzary, is to leverage LoRaWAN to measure these emissions for each vessel traveling through this 80-kilometer canal. So the LoRaWAN, for the reasons that we know, ease of deployment, long range, et cetera, was the right choice. So Eric, I'll leave it to Eric to expand on the
Hi, how are you?
use case.
Thank you for the introduction. What do I do here?
Forward, green. Yeah, let me sit over here and keep you company.
Okay. Well, like Carlos said, we have full house. So I see very familiar faces. So basically, Senzary, it's become an end-to-end provider of solutions. We have created a pretty significant ecosystem of sensors, best-class products from Europe, Asia, and at the same time, through data mediation platforms, create solutions and design behaviors that can also be routed over to a number of other application partners too, that are also best class in what they do for different verticals. In this particular case, we were able to perform this entire project pretty much completely within our own platforms, and it was a very interesting approach that we were requested to do. So in general, as they said, there is a commitment to reduce carbon dioxide, and there was an idea of deciding of how can they measure this. So we were hired, we won an international bid to devise a methodology so that this could be measured. Nobody knew if it could be done, so we looked at the place, we understood the dynamics of the area, and then we selected different objectives. One of them is to do this engagement in context of the international MARPOL rules. And you see that the emission controls that, and the objectives are very significant in the need for reducing the emissions controls of these vessels. So in that context, we selected several key locations, as you can see, across the 6 locks. We used the Kerlink gateways in order to obtain the coverage. We did some analysis, and out of that, we also installed sensors for meteorological studies from Malsite, and some very sensitive sensors from Cinetica in the UK. So we assembled all of this stuff, and we pre-integrated everything. So by the time it arrived to the Panama Canal, it was pretty much plug and play. We actually did the whole installation with a technician that had never installed anything in IoT ever. So I think that part of the insights of what's going on is that we're slowly getting to a point where these types of deployments are, if planned properly, obviously, can be done in a very discrete fashion. And I think the partnership, in this case, between Kerlink and Senzary is great, because those gateways, for the most part, are pre-arranged from factory to hit our platforms. So it becomes a little bit of a plug and play, thanks to my friend Benoit here. And so it makes it a much easier job to do these kinds of things. The other thing is we were able to create the digital twins of all this physical infrastructure in our platform, and we also integrated with the WANC for all the management of the sensors and the analytics of the connectivity. But that was integrated in the context of where the ships are and the registrations, so everything was mapped inside our platform. This is where you can see more or less the process for developing the digital twins, where we integrated with the International Marine Traffic System to obtain data from all the vessels, and then we filtered that through the vessels that we were interested into. We developed some geozoning and APIs with those organizations to obtain the information that we actually needed. Then we enriched the data and injected all this information into the platform, associated with each one of the ships and associated with its traffic through the canal. Then another aspect of installing IoT solutions is dealing with errors, dealing with problems. How do you troubleshoot and make sure that you have all the tools and the processes available to understand and interpret all the stuff that goes on between the sensors, between the gateways and the backhaul, the telemetries, the configurations, and in this particular case, very specialized configurations for the purpose. So it's a very close relationship that we have, and it's a proof of the ecosystem between the several manufacturers and vendors and ourselves to really work together to accomplish something like this. Another thing, we have business analytic platforms that we use for many purposes. In this particular case, I developed this in order to analyze the signal process across the whole Panama Canal, across all the sensors and gateways, so that we could have an ongoing real-time monitoring of the quality of the signals. As you can see to the left and the bottom, there's a rogue guy over there, and that was pretty much about a little more than a mile away, but everything else, but you see the blue on the right side. Eventually, those problems were fixed, and then now you can see that the blue is on top on the right. It was pretty much changing ADRs and forcing some communication sub-bands between the gateway and the sensors, and that was a tool that we use for balancing these things. We cannot provide all the information because of confidentiality aspects, but in general, we were able to incorporate all the data, as you can see from the vessels. We were able to match that with the telemetries from the weather, match that with the telemetries from the sulfates and stuff, multiple levels of sulfates of different variations in there. And all of that also mapped against the speed and the direction of the wind prevailing at the time of the measurements. Okay, so all of this stuff is processed into our platform, our logics, and then we re-inject a new set of telemetries that incorporate all this information in a way that can be digested by reports and humans. So at the end of the day, I think that the key points is that it's amazing that we were able to deploy a network for a consulting engagement, that this was done under 1 month, and that it required only 1 visit, and that everything else was done remotely. The other important aspect is that we were able to detect these sulfate levels from the emissions, and that the theory that we had actually worked. So we did like very precise geozoning metrics so that we could prove that the emissions pertain to the specific vessel going through it, and then we had to take away other measurements that were the surrounding values that were affecting potentially those. And, but the engagement was to learn, and we did, what else do we need to do in order to improve the quality of the measurements to a point of being legally correct. So that if we measure and we certify, it needs to be in such a way that it can be used to fine a ship or to provide a benefit to the vessel because of complying or not complying with the certifications. So this is a pretty important part of the process, and I think we were able to successfully do that. We measured over 1,000 ships in December alone, and the results were really incredible. We were also able to create, which I cannot show, the whole aggregated cloud of sulfur from all the ships together with using international models for dispersion of gases applied into the IoT platform. So we were able to create the whole cloud of sulfur, which is repeated continuously as all the bulk of the vessels traverse the canal. So it's a very significant topic. Now we are in the process of going to phase 2, where now that this is being validated, we already presented, I don't know, like a 200-page study from this. And in there, basically, we recommend the new infrastructure that we suggest in order to make this super accurate. And in addition to that, the next phase would be that we become like the certification entity, providing the information that allows them to either find somebody or provide a benefit to somebody. If you think that there's $600,000 that a vessel pays to traverse the Panama Canal, and 1 day that they give them a free passage, it's about $150,000. Multiply that by 10,000 ships, and it's about $100 million in the conversation. So, you know, this IoT solution, it's the cost of what we do, it's irrelevant in this particular case towards the benefit for the environment, the benefits for the organization. And I think this is something that now we want to take globally, because in researching, apparently we developed a very unique solution that allows for ships to be certified in measuring stations in different parts of the world. And they need to do that on a yearly basis several times in order to obtain green certifications. So I think this is a great use of the LoRa technology, the partnership with Kerlink, Senzary service and our applications, and it was a very successful case. So thank you.
Any questions? Yes.
In your implication, did you have any need or use to use the forward link of LoRa to set parameters on your sensor or anything like that, or was it always a return link solution?
I still don't get the question, I'm sorry.
Most of the LoRa installations are return link only. You get data from your sensors to your tower, right? But LoRa has the ability to do forward link, so you can actually send commands to your sensors, which is...
Yeah, this was bidirectional.
So you did use bidirectional in your implementation?
Absolutely, and actually when we were doing this configuration problems we found, we had to remotely work on the sensors in order to redesign the communication protocol between the sensor and the gateway, and all of that was done remotely.
And what kind of things do you use what kind of commands or settings did you adjust?
Every sensor has a different command structure, and our platform, in our platform we have multi-LNS capabilities first, so we can receive information from multiple LNSs, and then we have a record on how to talk back to a sensor regardless of where it came from. And also, we maintain a record of the last state of configurations, because in most cases, people send configurations to the sensors, but that configuration is not stored anywhere. So when you have maybe 1,000 sensors, now you don't know which ones are configured how. So we've been adding capabilities into our platform that I think are important when you're like operating something. And so we're integrated into the LNSs, we get all that data, we add and enrich that data, create new variables, new attributes, new servers, we create new telemetries. And that's why we call it data mediation platform, because it's really something in between the raw things we get and the clean things that we need, you know?